determine whether the series is convergent or divergent. So we got the general term an negative 2 to the n over n. When we got negative number raised to n, we get plus minus positive negative or negative positive negative positive. That means this is an alternating series, and we can use alternating series test to show convergence. But here the question is asking whether this is convergent or divergent. So the alternating series test can't be used to show divergence. So I'm not going to use the alternating series test. Instead, I'm going to use the root test. This can be done, this can be shown convergence or divergence using the ratio test. See my other video for the same problem, but I'm using root test here. So nth root test pretty much. So we take nth root of absolute value of general term and take the limit. If this limit happens to be less than 1, this series converges. If this limit is bigger than 1, this series diverges. If the limit is 1, this test fails. Then we need to use a different test. Okay, let's use that. Limit n going to infinity of this nth root is in fact something raised to 1 over n. Okay, nth root means pretty much quantity raised to 1 over n, and absolute value of an, which is negative 2 to the n over n. Now let's take the absolute value. Absolute value of n on the bottom is just n, because n is always positive, it's going to positive infinity. But negative 2 to the n, when we take absolute value, it's gonna be negative 1 times 2 raised to n, and we have absolute value negative 1 to the n times 2 to the n. Now this negative 1 raised to n, that is negative 1 positive 1 negative 1 positive 1. Whenever we take absolute value, it's going to be just 1. That leaves just 2 raised to n, and this is always positive. So negative 2 to the n, when we take absolute value, you can simply ignore the negative sign. So 2 to the n, and we have exponent 1 over n. So limit n going to infinity of, on the top, 2 raised to n raised to 1 over n. So this exponent and this is a product. So that's pretty much like this. 2 raised to n times 1 over n. n times 1 over n cancel. So 2 raised to 1, which is just 2. So on the top we got 2, on the bottom n raised to 1, so n raised to 1 over n. Now we need to take this limit. There is nothing to do on the top, it's 2, so this limit goes on the bottom. And from calculus 1, n raised to 1 over n, when n goes to infinity, we did L'Hopital's rule in fact, and we found that this limit is 1. The whole idea here is we can convert this into x 1 over x, and when x going to infinity, we can take natural log both sides and go from there. Or you can get this idea: when n is very 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 big, 1 over very very big is kind of 0. This one goes to 0, this one goes to infinity, but this one goes to 0 faster than this goes to infinity. You can check. 1 over very big becomes much smaller. That means a number raised to kind of 0, so this limit is 1. But actual proof is L'Hopital's rule. Anyway, this is 1, this limit is 1, so 2. So we got this whole limit 2, which is bigger than 1. That implies the original series diverges.